Good evening,
Well,
and thanks for joining us for episode 4 of Hot Topics with Hot Rod. For safety's sake, maintaining safe water building systems in the 2020s. I'm Erin Holohan Haskell, president of heatinghelp.com, and we've had a ton of fun partnering with Caleffi on this webinar series. So a huge thank you goes out to Team Caleffi for all of their hard work behind the scenes. And thank you to Bob Hot Rod Rohr for sharing his knowledge with us. So here he is, tuning in from his workshop on Know-It-All Lane, our friend and industry expert, Hot Rod Rohr.
Well, thanks for the nice intro, Erin, and welcome everybody. And actually, I'm in my office and I was too hot out in the shop, so you might notice a little different background, but I got some air conditioning going on in here. So yeah, so the topic tonight is going to be mainly on domestic water. We're not talking about heating stuff tonight. We're going to talk about, call it potable water, domestic water, basically the water that we drink, that we shower in, and stuff like that. So a little different spin than what I usually talk about hydronics. But I think I got some really good information. I got Kevin's on board with me. He's up in Milwaukee, and he's going to field questions. And he's done this presentation quite a few times too for different ASPE and ASHRAE groups. So he knows the information. We're going to maybe banter back and forth a little bit to make it a little bit more fun and interesting. So let's get rolling here. We got a couple housekeeping slides. Yeah, this is the typical, if your system is giving you a hard time with the connection or something like that, that's a tech support line for the GoToMeeting folks. They can sometimes help you through a connection issue. Most of the time, if you have a bad connection, if you just log out and log right back in, it'll clear it up for you. So we have all the back issues that we've done so far. We've have them on the YouTube channel, both ours and also at Heating Help. So if you want to watch one of the past ones, and this one will be up in probably a couple, 2-3 days from now, we'll have that archived also. So if you want to watch it again or share it with somebody, there'll be a couple places you can find it and do that. And so, yeah, so that's where we've been, and that's where we're going tonight, episode 4. And then, we're going to think about what to do for the fall season. We like doing this, and we think it's pretty well received. It's just, we got to come up with fun and interesting topics for you and me. So we're going to take a little bit of a break and then, re-examine it a little bit, maybe more in the fall. I think people might be getting a little webinar weary right now with the summer and stuff. They want to get out and do things. So, but we'd love to do some more of it. So, in the spirit of our chairman, Marco Caleffi over in Italy, he was generous enough to give €1 million to a couple different hospitals there in the area to help with the COVID thing. So we thought we would do the same thing, not to that dollar amount, unless Erin's going to step up for €1 million. But I don't know if you can read it over here, but they shared that with a couple hospitals, one in Borgo close to where Caleffi is, and then one in Milano at another hospital there. So that was it was impressive as our president to do that. So we want to go along with that. And I'm going to let Erin talk about this mission a little bit more. I read up on it a little bit, but I think Erin has a little bit more information on it. And that's what we're going to do is $2 per attendee up to $500. And the past ones, thanks everybody for the past fundraisers that we've done. We've pulled in some good money for these different charities. So thanks for your support on that.
Thanks, Bob. Yes, Water Mission builds safe water, sanitation, and hygiene solutions in developing nations and disaster areas. Today, they are providing urgently needed solutions to at-risk communities during the COVID-19 pandemic. Both heatinghelp.com and Caleffi will donate $2 per each individual who attends tonight, up to $500 each. So just by tuning in, you're helping us support those in need and combat the spread of COVID-19. If you'd like to learn more about this charity and the great work that they're doing, visit watermission.org. And thank you so much.
Yeah, thanks everybody. That was well put. I did go there, and what I learned just tonight before I logged in is that it was a husband and wife that started this after Hurricane Mitch, I think it was, hit Honduras years ago. What was that, 98, I think, or something like that. And he was an engineer, an environmental engineer, and the Greens, their last names, and they just said, let's just keep this going. So it's been a pretty popular, and they do a lot of good work all over the world, both for, like Erin said, for domestic water, but also for wastewater too, trying to go into places where they can help with that. So we think that's a good one that fits it nicely with tonight's topic. So yeah, thanks, gals, for doing that. Now, as far as the topic on water specifically, we don't have a product for filtering water or that, but we do have a couple things that towards the end I'll talk about that can help with some of the issues with water in these buildings, especially buildings that have been vacant for a period of time, which is Legionella bacteria. So we're aware of that being an issue in the industry and the world, really. So we do have a couple products that we developed for the world market, for the European market, that we've recently, in the past couple of years, brought over to the U.S. So we'll talk about how those work and what they can do for you, and the whole reason why we have a product like that. So, and those are two of our hydronics that we talk about that in detail a little bit more. So Legionella, and jump in any time here, Kevin, on this, because I know you've done a lot of research and you've got a lot of background on this. Now, there's other bacteria that can certainly be in your water, from Giardia, that from cattle or something near your well, to iron bacteria and a lot of different bacteria. But I'm going to focus on the one that most of us hear about. It's in the news almost every day somewhere, Legionella bacteria, just because it is. It can be deadly. Number one, it started our awareness, I think, in the U.S. probably started with the the Legionella get together in Philadelphia years ago. And if you start looking around, what they've discovered is there's probably been more cases and outbreaks of that were written off as a flu virus or something like that. So once it's in the news and once the legal system gets a hold of it, it's hard to ignore this. I was recently in Florida with one of our reps down there. We're driving we were going from Orlando to I think Tampa somewhere, and we're going across one of the interstates down there. There's actually billboards down there. I think you might have contacted Legionella at one of the theme parks. You call this certain attorney. There's attorneys that just, in that corridor focus on Legionella of all things. So go figure. But that's, once it's on billboards and the word's out like that, we've got to, well, I've got to address it in any case, but it's, once it's on people's mind, it seems to get a lot more attention from all the different code administration people and stuff like that. So. Yeah,
that's all good stuff, Bob. All good stuff. Another reason too is you mentioned here the flow rate in the mains dropping. The low flow fixtures are a main contributor to this. So we're bringing much less water in from the municipality, right? So that water is older. So the water sits in the buildings, and we have old water, much more than we used to. And more testing, and the water age is a big contributing factor. And then of course, the retirement age people, seniors, there's more of us these days too, so there are more people that are susceptible. So quite a few reasons for the cases being on the rise. And then the testing too, the data you mentioned there too, they're coming out with specific tests now.
Yeah. And that when you talk about the, how, low flow on everything, shower heads, toilets, hand sinks, even when you go to a public restroom, they've got little low flow faucets. So that affects not only the piping in the building, but also the water mains out in the street. They're not getting as much flow as they did, going back years. So they get biofilm can grow inside the mains, the public mains. So that's where we're going to go with this next. So what is, first of all, where the water starts out, the public water suppliers, what are they doing about it? So let's do something a little fun first, and we'll do we got a couple of trivia questions tonight. This is the first one to win the Hot Topics t-shirt. So this was a clever one. Aaron came up with this. I like this too. It kind of wraps up everything that we've talked about over the last 3 episodes of this. So what can water do that no other substance on earth can do? So we'll give you a couple minutes to talk about that. Did you know the answer, Kevin, when you saw this?
No, I don't.
Spot there.
I still don't, so I'll learn right along with the rest of us.
Yeah, once I read the answer, it said, oh yeah, that makes sense, but you don't think about that only water can do this. So we getting any responses there, Mary? Kevin, I don't know who's watching the poll numbers.
Actually, we do have an answer from Gary Klein, and his answer is that water can be in 3 phases at the same time. Does that sound right?
It can be in 3 phases. It can be a liquid, it can be steam, can be a vapor, or it can be a solid. So that's exactly right. I didn't think it's at the same time. That puts another twist to it. I didn't think that far along. I just knew that it could be a solid, liquid, or a gas is what the answer that Aaron was looking for, but we'll take it. He's right, and I'll leave it to an engineer to have that on the tip of his tongue, right? Hi, Gary, by the way, we've talked and we've worked a little bit together, so thanks for tuning in tonight. What do you think, Kevin?
Good answer.
All right.
I was going to say it evaporates, but maybe other things evaporate too.
Yeah, well, what is the steam, I guess, eventually. So here's the thing about Legionella. It can be, it is an airborne virus. So, you know, going even back to the Philadelphia outbreak, they're not certain exactly where that came from. If it was, they say the cooling towers, that was the most logical, but it could have been a water feature. It could have been in the shower, but just that it got so many people at one time like that, they kind of look to the cooling towers, maybe the cause of it. But this is kind of different places where you can get it airborne, where it can be in the air. The cooling towers, of course, on the left there, and water features. You see more and more places they're filling in their water features, or turn them into gardens, or turn them into something other than a water feature just for that reason. And I'm thinking, gosh, Vegas, all these years, all those fountains and all those displays and stuff, and that one wall of water at those recent area on the strip there hotels. I'm thinking, all that time and money to build those, and now they're shutting them down just you know, for the potential to be spreading this bacteria. It's out there. It lives in the ground. It's around us all the time. It's just that once we get it you know, moving around through the systems, that we can breathe it, and either from the mist from a shower, or walking by one of these features, or again in the cooling tower vapors. That's when we have a problem. And swimming pools, even a home spa, I suppose, if the temperature gets right, that's a perfect breeding ground for it. So what, if you have water that comes from a public water provider, they're bound by certain regulations. There are different associations. There's just different rules and requirements, especially if they get public funding or they get government money. They have to meet all these mandates for testing. And the group that kind of watches all that and keeps track of all that is the AWWA, the American Water Works Association. And so over the years, they've come up with a way, you know, policy and a checklist of how you can disinfect the water mains, and starting right at the source of the water, what they can do to treat the water, and then make sure that their mains are treated or tested occasionally to do it. So their job is just getting the water to you safely. Once it's in your building, once it's in your lines, then it's your responsibility to maintain that water. They just go to the, you know, to the end user with their liability, I guess you would say. So the thing that they worry about is, you know, right now, of course, is lead pipes. So they want to keep the, they want to keep a little bit of a biofilm inside their water mains to keep any leaching of brass or lead out. So it's kind of a juggling act, that they want to keep a little bit of film in there, but not enough film that, you know, bacteria can have a nesting ground or a breeding ground and stuff like that. So it's a tricky balance for them to be able to do both those things. So you know, we're assuming they're doing their job, and now it's up to us to take it from the building in, and, you know, how we do that's going to vary a little bit. So I had an interesting, attended an interesting webinar here maybe a month or two ago that some of you folks probably know. Ron George, he writes for the magazines. He's on a lot of different committees. He does a lot of training. He's an engineer. This is kind of one of his pet topics right now, and he was generous enough to share some of the research he did, which saved me hours or days of digging all this stuff up. And he presented this to the ASHRAE, was it Detroit chapter here just in July, I think. So this is pretty current information, but yeah, he had 50 slides like this where he really drilled down on, you know, how they do the disinfecting. And what you'll notice up here is on the flow rate for flushing up piping. It's not that unlike what we do in hydronics, where you have to get that flow rate up to a certain velocity, which we call feet per second, is how we measure that, to make sure that you're moving that the chemical that they put in through the pipes, and that you can get it, you know, in contact with the film on all sides of the pipe. If you think of what's the example show there, like a 12-inch main with just a trickle of water going through it, where one person's opened the faucet, it's certainly not going to move all that water through there to be able to flush that pipe out. In fact, that's a little demo that I tried to put together just to have a shop theme to this. I wanted to put a demo. I said, well, how could I best do that? So Max got together with me and had some pretty good ideas. So we're going to show the demo first, and then we'll come back to, so here's what it kind of came down to at the end after I had this all done. I said, well, here's the two worlds colliding. Here's a, you know, just a backyard plumber and myself thinking of how I could demonstrate this. And here's Ron coming up with, and Kevin too, we'll show some of the slides that he researched, coming up with all the data, coming up with more of an engineer's approach to how you would approach a problem like that. To me, I'd say, well, you just need to move more water through, and we'll just open all the taps until that happens. But, you know, you have to have a little bit more documentation to it, especially if, you know, if there's a health safety issue that's involved with that. So what do you think, Kevin? I thought this was a clever way of, you know, presenting that, showing the size of the pipe and what kind of flow rate you would need through that piping to get up that 3 feet per second that the AWWA is recommending.
Yeah, Ron always has really good detail in his slides. You can spend 5 minutes on some of these.
Yeah, well, that's the thing. Some of the slides were so complicated. My eyes were starting to cross just trying to read it all, make sense of it. But that's, I mean, it's all pertinent information. It's just, you know, these slides are available to everybody that's viewing tonight. So if you want to read through this a little bit more, but that's the bottom line of this. He wanted to show what kind of flow velocity it would take to get to scour different size of mains. So these are some of the sources that are available right now. You know, who's doing what as far as giving us some plans or giving us some information to build on. So we've got the ASHRAE standard down here, the 1088 standard. When it first came out, people said it didn't go far enough. You know, it said you got to develop a plan, basically. Well, okay, how do I develop a plan? What should be in my plan? So they're drilling down a little bit more. What's happened is some of these groups got together. You can see the CDC's involved now, the NSF is involved, ASHRAE's still involved. So they're trying to, you know, make it more than just a suggestion. Here's the things that you can do, and here's how you would do it. And you'll see as we get to the end that Ron's put together a little assessment plan too. That's, gosh, about 15 pages of information on how you would check and document and what you would have to do to protect your building. So again, assuming the water gets to your building safely through the public water provider.
Yeah, and 188. Bob, oh, I'm sorry to interrupt. That new version, the 2018 version is written in enforceable code. So they changed the verbiage so that an engineer or designer can literally, you know, cut and paste sections of that into a building spec, which was really nice. It was a good improvement to that. So it's a great document. It's not really very long. So I'd encourage, you know, everybody who's interested, go ahead and read it. It's not, you know, too long and too deep. It's easy to understand.
Well, that's good, because sometimes that can get a little bit too, where you have to be an engineer to understand it. But you can see up on the top that he put a red box around. One's a guideline and one's a standard, and that's what Kevin's referring to. So this is an enforceable, which will probably be built into the codes here soon. You know, it takes a couple of years to make their way into the different codes that we have around the country, and of course for the different jurisdictions to adopt that code also. So. But this number 12 is the difference between the guideline and the standard, Kevin. Is that what the verbiage means there?
Yes, yeah, the 12 is really nice too. It's a great read. It was just updated, but what it does is it gets a little more specific. It actually talks about you know, storage and thermal disinfection and copper silver ionization and other things. It gets a little more detailed on what you can do, instead of just saying you have to have a plan and you have to have a team that's responsible for the plan. It actually gets into some really good detail.
So these would be where a building owner, let's say you're a hotel chain owner or something like that, you would go to one of these and you could add on to this. You could certainly build more into the, you know, a plan that you have for your own buildings, or a documentation, how you're going to keep that documentation, or who's going to be in charge of this. And that's, you know, I think that's what the industry has encouraged the building people to get involved and know about this and what to do about it, and how to test and keep the buildings maintained safely. So. All right, so here's my demo. I think I can just click on this here and I look at my IT personnel with that. Now I'm going to talk through this one. It was a little noisy when it was running. So when we first tried, I said, I'm not going to be able to hear me talking. So basically what I did, I thought I'd make it green that looked like a Legionella. If Legionella is a color, I would assume it's green. So I made a big column of water there. So that's a piece of, I guess it's about 1.5 inch ID pipe. And I filled it up with room temperature water. And well, I'll just start running this and we'll show you what I did. So basically I wanted to show what would happen if I had just a little hand sink faucet running there at about 0.35. We actually put a little flow setter on it to get it down to a certain flow rate, and watch the column of water, the green color there, and see how long it takes to, you know, flush that column of water. And that's only 5 feet, 1.5 inch pipe. So think of that, you know, the previous slide talking about a 12-inch main or a bigger main like that. It took, you know, about 1.5 gallons of water to flush out of there before you can even see the green color start to disappear. And if you're close to that, you'd see that the water doesn't just flush that whole column out cleanly. It just kind of trickles through the center around the edges, because as you can see the flow coming out of that faucet versus the pipe that's feeding that, it just didn't flush it out. So we looked at that with both a infrared camera we had on it also, to try and see the change in temperature as we were running that. So Let me get back to my slides here. Thanks, Max. So yeah, so that's the difference between a power flush and just opening the water is you just got to move that whole volume of water. So now every building's going to be different in that respect. You know, if you got a 3-inch main going through a building, or if you got a 12-inch main going through a skyscraper somewhere, you got to know how much water to go through there. And here's an example, again, out of a job site, that what it can look like after it sits for a while in those mains in a building that hasn't been used for just a short period of time, just a few months period of time. That water can get stagnant and pick up the bacteria if it's in the piping, is in the biofilm and stuff like that. So now you're going to have to flush that main until this color water goes out of there, and you get down to this color, and you know that you've pulled the new chemicals that were put in by the public water provider, have been pulled back into that building, the chlorines or the chloramines or whatever different chemical that they're using. So the tricky part, the part that we still don't have an exact answer to, are what we call the dead end legs in the building. So if you got a couple risers going up to the building and you branch off for, you know, maybe different wings or something like that, how do you assure that that whole system has been flushed, that you've got water down to the very end of every one of those dead legs, insufficient amount of flow to get to this 3 feet per second to adequately flush those out? So it's not going to be an easy thing to do on a big building. You're going to have to go in there and, you know, get some way moving a lot of GPM to flush those pipes out adequately. So.
Yeah, and your video really showed that, how to, you know, if that fixture was on a dead leg, right? I mean, you ran that for quite a bit. Now that's a really good example of flushing that stagnant water just in that little piece of pipe. Imagine if you had 50 feet, you know, from that fixture back to the recirc line or something, how much you have to open that fixture to get that dead water out of there.
And I don't know that you could through a little, especially if you got a you know, a flow restricting faucet like that one there. I think it had a 0.35 aerator on it because it was a you know, water saving, you know, a lab faucet there. So at some point you almost have to come in with a pump or something like that, or be able to open a big flow. And that's how the public water providers do it. They'll open a hydrant on a water main to flush enough GPM out of there to make sure that their chemical was contacted all the piping. Obviously, you don't have that ability in a hotel room. In fact, even if you could, you probably wouldn't have enough drain capacity to handle that kind of flow rate to do that. So there's some unanswered questions out there, but at least people are thinking in that direction and trying to come up with a plan. So we think thermal disinfection at Caleffi is probably the best way to do it, you know, because it can be done with the equipment that you probably already have in the building. Just elevate the temperature and recirculate it through the building for a period of time, at least on the hot water side of it. So the question becomes, well, what temperature, you know, how much do we have to raise the temperature in that loop, and for how long to do that? I know, Kevin, you know a lot about that, so I'm going to let you talk to some of this too, but there's a couple different, I'll just bring up all the talking points here.
Yeah, sure. Well, to do this, you have to have an electronic mixing valve, right? And here's a few examples of those types of valves. You can't do it with a thermostatic mixing valve without making some kind of bypass piping and doing a manual. I mean, it's just really not practical. So you can do it. All these valves shown here have the ability to elevate the temperature for that period of time. And like you say here, Bob, 10 to 30 minutes, kind of depends on the type of system and how old it is. And then we get that question too, activate daily or weekly. You know, how often do you have to do this? Well, that again depends on the size of the system. But like you said, Bob, it really is the best choice. You know, you're not adding chemicals that you have to control. You're not spending money on those chemicals. They can be dangerous. It's better for the environment. You don't have to dump any water to the sewer. You can actually just elevate the temperature and then return it to normal, so you don't have to waste any of that water. And you know, this has been used in Europe for decades, that point there. So it's a proven technology. This is not new to North America. It's just that we're just now starting to do it with these electronic master mixing valves. And once you have this in place, if it's already controlling your domestic hot water, everything's already there. You don't have to even spend any more money. You can just elevate that temperature and do this. And we're going to have another slide you have later, Bob, shows exactly how we do that, you know, the actual process. We'll talk about that again.
The one gray area out there is what temperature, you know, and for how long, like Kevin said, and that would depend on the building. I mean, like I said, I was in a building recently down in Oklahoma City that's been closed for, gosh, months now. In fact, half the building was roped off. It was I think it was a Hampton, I stayed, no, it was a Marriott actually. They had the parking lot roped off. They had half the building roped off, so you couldn't even go down there. So, you know, that building, it's going to take a bit of water to get every one of the, let's say there's 50 rooms on that side of the building, you know, every one of those pipes in that building is going to have new contact with the water. And the other thing that happens with, you know, going back to that earlier slide with the water providers, they're having these same issues that, you know, the chemical that they put in has a, I don't want to call it a shelf life, but it has a period of time that it starts to lose its efficiency. And if those mains aren't being flushed through adequately, they're not keeping up with, you know, the chemicals that are dissipating, just, you know, getting used up as they're sitting in that piping. So they've got to deal with that on their end to make sure that the water, you know, is safe, that the chemicals stayed in until it gets to your final use. So getting back to these temperatures, wasn't it the state of Illinois, Kevin, that was trying to say maybe we should require 160 degrees? No, the reason for that is,
yeah, I think it was the city of Chicago
okay,
that was trying to do that. I don't know that that ever happened, or that they went through it. There was a lot of feedback relative to that, but you don't really need to do that continuously. I mean, of course, it would kill the bacteria, but just think of all the other, you know, things that would happen. You know,
yeah.
the equipment, that's hard on the equipment. That's you're going to have a lot of scale, you know, increased scale, right, Bob? Because at that temperature, you're going to have more hard water deposits coming out of solution. And what
Yeah.
you want to do is just elevate it just long enough to kill the bacteria and then let it go back to normal.
I think maybe somebody there was thinking, I don't want to speak for the city of Chicago or whoever, probably some engineers that said, you know, if we go to 160 and we've got mains that have or buildings with pipes that have a lot of biofilm, maybe it takes that high a temperature to make sure you get through that biofilm and you get all the contact with all the bacteria. I think well, I'll show you some pipes coming up here with maybe a ½ inch of slime on the outer wall that they say, well, maybe that 140 degrees isn't going to get to the bottom of that slime layer where stuff could be living in there. So maybe that's the reason that they talked about it. And also, I think in Europe, Kevin, some of the standards over there say your time period can be short at the higher temperature. So instead of going 30 minutes like we show here at 140, you can get it over, so to speak, quicker at a higher temperature. So, but yeah, your equipment's going to take the hit on that. And of course, the cost to raise the water up to 160 degrees and then obviously mix it back down to a safe, usable temperature. Yeah, there's a lot of things that you have to think about when you start talking about elevating that temperature. And then you need some way to trigger whatever's generating your domestic hot water. When this valve says, okay, I'm in that mode, I want you to go to a high temperature for your bacteria protection mode, you've got a trigger through the, you know, we've got a relay in here that you can do that, but the device that's making your hot water has to be able to accept an input and says, okay, at that time of day, I'm going to elevate my temperature so that the building has that temperature available. It's one thing to, you know, ask for it, but the equipment's got to be able to, you know, have the logic built into it that it can go to that high temperature. So,
right. So if your building has a electronic master mixing valve in it now, and you go back to occupancy, you know, from being unoccupied back to occupancy, then you can easily just set this valve to do the disinfection. So I mean, that's a lot easier than you know, getting a bunch of chlorine and dumping that in the system and then dumping that down the drain and that kind of thing. So it's another advantage of having this kind of valve.
Yeah, and like Kevin said, we've had these out for years over in a lot of different markets throughout the world. So we think we've got a pretty good idea on what does. I mean, there's been Legionella standards in Europe and Germany, different places for what, 10, 15, I think 15 years now. I think they were telling us in Italy they've had a standard that they had to build to, you know, build a valve to and build a mechanism to. So that's where we look to them for, okay, what have you been doing over there? You know, sometimes it's easier to copy a standard or a, you know, procedure that's already been built and tested and proven as opposed to, okay, where do we start, what temperature we use and how long. So this is maybe a little better graphic of that shows the, you know, the issues with supplying a building, like Kevin said, with a super high temperature, sitting 160, even 140 degree water. You know, the potential to the seconds that it takes for somebody to get a second degree burn is considered, if you raise a red spot, a blister on somebody's skin, that's considered a second degree burn. And that's where, of course, the legal issues come into play when somebody gets burned like that. So with that in mind, you're going to have to protect every single tap in a building, whether it's a tub, whether it's a sink, whether it's an eye wash station, a bidet, whatever it might be that has hot water going to it. You're really going to have to look into putting point of use, you know, a valve right at every one of those fixtures to give you that adequate protection. So when and if the building goes up to a high temperature, midnight tonight or whatever it might be. Think of this red line here. This hot line is going to have 140 degrees. If somebody gets up, to use a faucet or something like that, we've got to protect them under all the different conditions that this temperature could be at. So that's where it's going to get a little bit more involved. You're going to have to start looking at these point of use valves, like a 1070 valve. Some of the shower valves, like single handle valves, have that built in it or could have that built into it. But if you have a two-handle tub valve like this, or even a two-handle lav faucet, or even the single-handle faucets that you see in a lot of like public restrooms, where you just put your hand under it and warm water comes out. Well, they've got that mixed underneath to give you that temperature that comes out of that, because you don't have any way to regulate that or adjust it. It's a hands-free type of application. So there's a lot of questions, and we're trying to come up with a lot of answers for all these questions. Okay, we're going to do this. Help us out with ideas, with products, with piping diagrams and stuff like that. And this kind of talks to what Kevin and I were talking about, activating the with some relays, activating the both the pump and also the higher temperature mode of the boiler, the indirect tank, whatever might be providing water, even tankless. A lot of these smaller hotels now that we visit, these little interstate ones have tankless water heaters. You drive up to the building, you'll see like 6 or 8 vents coming out of the side of the building, which are all tankless water heaters. So those are going to have to know that it's that time, to go up to their high temperature mode to provide this disinfection cycle.
Yeah, and this slide shows how the Caleffi Legio-Mix actually does it. So it's interesting. I can go through that. So
yeah.
It's the only valve, by the way, Bob, that will automatically do this thermal disinfection cycle. In other words, there's a calendar and a clock in the Legio-Mix controller, and you can set it up if you want to automatically perform this thermal disinfection. And how that works is, let's say, if you look down at that line graph, you designate that at 2 a.m., okay, you're going to start your cycle. So what the controller will do is it'll elevate the source temperature up to 160. So there's a contact output that says, okay, heat source, go to 160, or if it's already there. What it does is there's that relay 3 over there. You can see that it will, or excuse me, the relay on the right, it will make sure that your recirc pump is running. For example, you want to make sure that's running. So that's in that relay is wired in parallel with your time clock or your aquastat or whatever else is controlling your recirc pump. And then it's going to automatically change its mixed temperature set point. So what you might normally have set at, say 130, if you look at that graph, the dark red line, that's my set point. Okay, that's my mixed temperature set point. So the controller will at 2 o'clock say, okay, let's go to 160. Let's make sure the pump is running, and it will increase that supply temperature up to 150. And the dotted line there, what that is that's the return temperature. And actually that's the most important temperature. So when we start the cycle, the controller will watch the return temperature sensor. And as long as it gets up to 140, then these are examples, you can change any of these. It will say, okay, I'm there, I'm at 140, I need to be there for 30 minutes. And it will watch that return temperature and make sure that you have a total of 30 minutes within this period from 2 a.m. to 3 a.m., okay? And if your controller will do that, if your system will do that, then the controller says, okay, we're good. We had a successful disinfection cycle. I saw 140 at the return for 30 minutes, and it will record that as a successful cycle. And what's important about that is the building owner or the manager can say then, yes, I have a record in my data logging information here that proves that I have safe and sanitary water. So that's one of the big things that's really important in Europe is there are legislation and laws that require you, if you own a spa or a hotel or something, and actual inspectors will come around and they'll want to look at that documentation and verify that you're doing this. So this is the actual step-by-step procedure of how the Legio-Mix does it. So it's fully automated. It goes into disinfection, runs a cycle, and then goes back to normal, completely automatic. So, back to what Bob was saying about the anti-scald valves, as long as you have those in all of your points of use, you can do this and it's safe. So I know that's a lot of words, but hopefully this gives you an idea of exactly how it works.
No, that's exactly what I wanted to hear is the theory behind it, because there's a lot of valves out there saying, we can provide this service or this function to your building, but you got to understand, you know, it's more than just taking that temperature up. Like Kevin said, this is the critical point. You want to know that all the piping in that building has been maintained at that temperature, not that the valve just elevated for a period of time. So that's where you have to know that by sensing that with a sensor on the return, but also data log that information, because that's where it's going to come down to, you know, the liability in the building. If they have another God forbid, another Legionella outbreak like they had in Philadelphia, and you had equipment in there that was supposed to take care of that, somebody's going to want to know, you know, how did it work, or, you know, why didn't it work, or something like that. So that's probably the biggest part of that, that type of valve, is that having the documentation that can prove it. And it'll alarm, right, Kevin, if it doesn't get to that point, for, let's say the water heater couldn't keep up with it, or whatever the case might be, or the control in this was off a couple of degrees or something like that, the control will let you know that it didn't have a successful disinfection cycle, right?
Yes, yeah, it'll generate an alarm and it'll put that in the data logging information that the disinfection cycle did not succeed.
Yeah. So here again, it comes down to what temperature we're going to use. You know, 160 is pretty hot water, and what you'll find is the life expectancy of whatever's generating your domestic hot water is going to be reduced greatly when you start going to those temperatures. So like Kevin said, if you can do it with 140, 150, that's certainly going to save some you know, wear and tear, and give you a little bit more life out of that. And the other thing we're trying to show here is just make sure that whatever the building is piped with, that the pipe can handle that temperature. Some of the older buildings where somebody tried to maybe slip in some PVC pipe that's only rated at 140 degrees, and now you start talking about, you know, 160 or maybe even higher for a period of time. Now you could have problems with the piping in the building. So existing buildings that were piped, or, you know, buildings that had leaded brass in them, you know, if they had a recirculation pump and that was put in 20 years ago, you know, you want to be concerned about that, because of the chemicals and the higher temperature now going against that leaded brass. You could have that issue, you know, some leaching out of that, the lead leaching out of that older style brass. So yeah, there's a lot of things to think about. So I don't want to overwhelm the people in, listening in tonight, but just, you know, you want to be educated on this when your customer comes to you. And wouldn't it be good if you were the expert in your area, in your town, that when somebody has a call like this, said, you know, are you the guy that can come in and, you know, set up a program for us, tell us what we have to do, update our equipment, so we can meet all these either mandates from the code, or a mandate from the owner of the building, or you know, if the federal government mandate, like on a veterans building, a veterans hospital or something like that. They're some of the first buildings to mandate this, even if the codes haven't caught up with that yet. They want to know that the people that they're you know, caring for are safe in those buildings. So yeah, all those components there. This was a clever, again, thanks to Ron for letting me use these slides. And I hadn't thought of this before, but here's another thing that can happen on this this dead leg. So, and this can happen, you know, if you've got a building that sits for a period of time, you can have a little bit of an air bubble, because any air that's in that system is going to migrate up to high points in the system, maybe the upper floors in the buildings. Well, this little air pocket here can actually act as a little hydropneumatic cushion. What I liken it to, some of you folks might remember, I don't remember, a plumber invented it, and I think Sloan bought the rights to it, but it was that power flush toilet that was out for a while. And every time you flushed it, the pressure would come back into that, and it would fill this kind of like submarine looking vessel in the tank with a high pressure charge of air in there. And boy, when you flush that toilet, don't be too close when you flush it. It just really blasted that down there. Well, that's the same thing that can happen here. If you compress this bubble in there, you can actually get this dead leg water now moving back into the mains and blended with this out here. So even though you've run this main at an elevated temperature, and you're pretty confident that you've had this, you know, treated with the high temperature, dealt with the bacteria there, these dead end legs, even if you ran this faucet, you can have this condition here where that can flush back into that main if you don't get this out. And that's where it gets a little bit more complicated. If you've got to go to every single tap, every single faucet in a hotel, for example, think of every building, every shower, every lab faucet in that, you know, the rooms in those hotels, and flush that out. And you still have the potential for this to, for these dead end legs to go back. Even the building is shut off and nobody's using this, you can still get this contaminated, if it were water, back into the main that's maybe feeding the side of the building that is still in service. So yeah, that was kind of, you know, I never thought about it that way, but again, that's what maybe some of the engineers think about. So now there's other products on the market and coming on the market that you can deal with dead legs. This is one of the, I know one of the PEX tubing brands offers a fitting like this. So what they're doing is they're trying to recirculate as far out as they can, which would be right up to the angled stop behind these lav faucets here. And they're using this U-shaped fitting here. So as the recirculation water comes around, you've got now, of course, you still got the supply tube from A to B here. That's, could hold a half a gallon of water, whatever it might be in that faucet, that supply tube. But, we're just trying to get it closer and closer to where the water is being used. Now, if you've got an old building, obviously you don't have a way to do this. This has to be plumbed into the system. So there's other people that are looking at putting like little Venturi fittings right here. So when there's flow going through there, kind of like a monoflow T, it would induce a little bit of a flow or a little turbulent condition and maybe try and blend a little bit water up into these little supply risers going out to your angle stops and stuff like that. So once there's that's where the Imagineering and the engineering comes in. Once there's a need for something like this, people start thinking of different ways of doing it. A U-shaped fitting, a little Venturi fitting, something like that, that we can limit the stagnation in those dead end legs. And this is the other thing. So for those in California, I know Gary, you're tuned in tonight. There's always been the issue about running the recirculation, the amount of electricity it runs to run it 24/7. So then we put timers on them, or we put temperature controls on them, and we shut them off for a period of time. Well, now which one is it, Kevin? The OSHA standard, one of the standards said, no, we really would like to see those pumps running all the time. Now you get a little bit of heat loss, you get a little bit of electrical consumption, but that's the only way that you could assure that a fitting like this could do its job.
OSHA and ASHRAE 188 both suggest to not include that circulator in your energy calculations, and that there's some ASPE documents too that say just these new pumps, they don't draw very much energy, right, Bob? I mean, they're really efficient, so don't shut them off. To keep the water moving.
And along those same lines, I mean, in any new buildings, I know out in California, they require I think it's 1-inch wall insulation on this piping, just knowing that is a heat emitter as it runs 24/7. And now your air conditioning is working against that too, of course. So you would want a smart pump, a pump that could modulate its speed to know what the demand is on this, the GPM demand. I think I got some pictures of that coming up. But also you want that piping insulated so you're not, water heaters running all day just to keep the loop warm. So yeah, there's a lot of pieces to this puzzle, and there's an example of how much heat you can lose from the piping going through a building. Now this is an ambient temperature. Think if that's in a plenum space or something like that, where the air conditioning is running while you're trying to keep this loop at a temperature of 120 throughout the day, and maybe 140 or 160 at a certain point of the day. You've got that delta T, that temperature working against you, so you can see the BTU per hour loss on just 100 feet of piping. You can see the difference that even a small amount of insulation can make. That being said, now you've got an older building where that wasn't done. Now what do? Now you're going to have to take a hit on, the cost of running that pump with insulated piping. So I think we talked about most of this. We're just going to go through it. So this is what I was talking about, the cross section of piping where you can have this biofilm. Typically when you cut a pipe apart, maybe I've got one in this drawing, maybe it's coming up. You'll see this biofilm layer all the way around the pipe. It's not, this is more like an aqueduct to me than a pipe, but it'll grow on all sides of this pipe. And the thickness of this biofilm layer in here is the key to how much bacteria can live in there, can multiply in there. And that's why the temperature that, whatever this water temperature is, it has to get all the way through that layer of film down to the very bottom bacteria, if that's what you want to call that in there. So, and of course the bacteria that's going through with the water, which is what you typically inhale when you're in the shower and stuff like that. And I think we talked about this graph right here, kind of a catch-22 on this temperature graph. I remember years ago when I was starting out in the business, water heaters just came set at like 140, 150 degrees. Well, then there was a lot of people, getting involved with soft tissue lawsuits. So then the water heater manufacturers started limiting the temperature that the water heaters could go up to, that you could physically set them up to. They started bringing it down to this. So the soft tissue lawsuits kind of disappeared. But now we got the issue with Legionella. So now we're going back to them and saying, well, we need the ability to raise that temperature up, up in this range here. So now they're saying, well, what's going to happen with the people calling us, they're getting scalded again because their water heaters are going up to high temperature. So, it's always something, and that's why we're promoting this type of valve, the point of use valve. And there's a lot of different options that can be built into a shower valve. There's a little, three-way thermostatic mixing valve that you might pipe in behind a tub. We just came out with this little H pattern valve that goes in really nicely here because you just bring your hot and cold into the bottom and you just go straight up to your fixture here. So it takes a little bit of the, you having to build the T for your cold water coming into it. So it's just a little wall mounted, low flow, highly accurate point of use mixing valve for sinks. What else on that, Kevin? I think we're getting down to the end here. I got a little time. Any questions coming in, by the way? I don't know if you had a chance to look at those, or Mary.
I don't know, Mark, are there any good ones in there? I've been a little busy with this other menu, but I can take a look.
Yeah, we have some questions that came in here. Let's start with, I joined late. Is this, I think he's referring to the thermal disinfection procedure or technique. Is this a recommended for residential systems such as 1 to 14 unit apartment?
Yeah, I would say it could be even an individual home, especially a home that's like a second home. Think of all the homes up in the mountains, the ski resorts or any resort, golf course, wherever, where you've got a condo or you've got a second home there that's just sitting there for months at a time with nobody using water. I would say those would be certainly a target for Legionella. So yeah, it fits all buildings. It's not just for, you know, multifamily buildings or public buildings or hotel type of buildings. If I had a home somewhere that was infrequently used, I'd want to come up with a plan for that also. And it could be the same thing we talked about, just obviously a smaller version of a mixing valve that could do that high temperature mode for a period of time. Maybe at some point, if we have a Wi-Fi version of that, as you're flying in that day, you can have your temperature elevate before you get there and make sure everything's cleared. But yeah, that's a good question. It's for any building that has water.
Yeah, it seems like it'd be more of a straightforward application because, for example, you might not have the complications that, say, having risers might present in recirculating, you know, enough, which is related to another question I'll ask in just a second. And I think that, you know, probably the relative cost of trying to manage in a smaller building other forms of thermal disinfection could be costly, whether it's chlorine dioxide or what have you, UV, for example. Whereas the thermal approach is, like you said, Bob, it's pretty much taking advantage typically of what you already have in place with it's you know, it's not going to be degrading to the materials.
Yeah, you just got to teach us some new tricks. Basically, is all we're doing. We're using the existing equipment and just turn it into a a smarter system. So going back to thank you again to Ron George. This is he started working on this a while ago and has put together. I'll show you a couple pages of pretty substantial flushing procedure. I mean, takes it out, okay, what size pipe you have, how many fixtures you have and stuff like that. Anybody that's interested in that, certainly get a hold of Ron. I mean, that's the business he's in, to help people with this, but he does a lot of this for the code committees and stuff too. So you can see these are some of the pages that are in that document I just told you about the flushing procedure. So yeah, it's not it gets involved. So I thought I'd just, again, a shout out, thanks for his information and how you can get a hold of him if you have an application or building, or you want to at least present this to somebody, maybe you do a talk for your local chapter or something like that. I'm sure he'd be glad to, if you ask him for permission to share this information, because and we all learn together. The more that know that, the better, right? So we'll get for time here. We can do more questions. We got another trivia thing, but if you've got a couple.
There's another question that came in from Gary. It's as relates to recirculation. What do we do about the branches of the circulation loop? So obviously that brings in a little bit of complication, right? Because now you got several circuits that. So maybe Kevin, you might want to talk about that, starting with the sizing of the circulator to begin with, but the problem with circulating through a balancing valve, I guess.
Yeah, well, a branch, it kind of depends on what you're looking at, but if it's a branch that's off of the recirc line, now this would be a small example of that, right? But instead of going to one fixture, say you came off the recirc line and went and served 3 floors, which you might do as well. The point about minimizing the dead legs is always true. You want to have piping, you want to avoid piping with where you can get stagnant water. So you either have to flush or come as close as you can to the fixture with your recirc lines. it's all about stagnant water. No matter what you do as a designer or a building manager, you either need to flush or disinfect it in one way or the other.
Yeah.
And then in smaller systems, you know, you brought up a question earlier, Bob, about residential. In a house that does not have a recirc line, in other words, a single family home, you might go through the whole amount of water in a single day, right? So then it's not an issue, right? Because, for example, the water in my house doesn't get very old at all. I mean, with a couple of showers and some washing dishes and stuff, every bit of that water is replaced every day. So it's not an issue in a small residence. It's only when you get into larger piping systems and potential stagnation areas that you need to be concerned about it.
Yeah, and like I said, we don't have an answer for every single building. You just, that's where your expertise comes in. You go to that building and say, okay, this is the type of building you have. Yeah, there's even commercial buildings, some of the old buildings back in New England that didn't have domestic water, even big apartment buildings that didn't have recirculation on. Now what do? You've got a multi-story building and all this piping and no way to even recirculate through it. So that's going to maybe that's where you get into the chemical option on something like that, because unless you can retrofit a loop or a means of doing that. Now there's retrofit, you've probably all seen those where you can recirculate the hot through the cold water, use your cold water as a return. I don't know. I'm mixed feelings about that. It's better than nothing at all, I guess, at some point, but now you've got warm water in your cold water. So now you're opening your cold water faucet to flush the warm water out if you want to drink a cold water. So, there's trade-offs, there's pros and cons to all those different systems, but we're going to learn more about this as we go. There's going to be clever inventions coming out. Somebody's going to hit on some unique piping methods or fittings or whatever it might be to address all this, because there's obviously a need, there's a market out there, and it's that's what drives us to build interesting things. So
yeah, you touched on something, Bob, that I want to mention. If you as a building owner or building manager want to add chemicals, what you are doing is taking on the responsibility of owning that water. The Safe Drinking Water Act, SDWA, actually talks about this and says if you treat the water that comes from the municipality in any way, then you are technically responsible for the safety of that water. So it's another good reason to use thermal disinfection. You get a master mixing valve that can do the thermal disinfection to protect the water, because as soon as you add a chemical system or a chlorine dioxide or any of those after the water has come to your building, you own it. And that's also a legality. It's a really good reason to stay away from chemicals and go with thermal disinfection.
Yeah, I mean, you're just going to have to look at the building and look at the options, and we'll help you with the thermal side of it. We're not chemical people, but if there's a need for what we do, we'd be glad to talk to you or help you with that. I kind of spoiled the next trivia question there a couple times when paying attention. So again, we'll go to that. I think we're about to the end here. Unless there's more questions, we can do those at the end. So there's the next trivia question. Once evaporated, a water molecule spends how many days in the air? And this, of course, it goes to the Legionella being able to be transmitted through the mist or something like that. So we'll give you a couple seconds to think about that. And thanks to Aaron, the giveaway for this is going to be the copy of Pumping Away. That's a legend in the industry. That little book right there has probably made more people smarter in the hydronic side of the business than anything else that's out there. So thanks to Dan for writing and for Aaron for offering it here. So we'll just give you a second to think about that, unless Mary, there's a correct answer already.
Well, you know what? We've got a correct answer. Dennis said 10 days in the air. I think that's a bingo. And Bob, I did want to just mention that one of our listeners must be from Illinois. Bill just said that when you cited earlier in the presentation that someplace in Chicago or Illinois was to raise that water temperature to 160. So he had a little bit of information on that, saying that was the state of Illinois was trying to mandate that to 160 degrees, but to date that has not been code, and that was as a result of a Legionnaire's outbreak in a retirement home.
Oh, so that was the state. Okay, thanks a lot. I thought that was the city. Thanks for correcting me, Bill.
Yeah, we
Yeah,
might have to
thanks.
get Bill a t-shirt too. What do you
Yeah,
think?
sure.
I do. Yeah,
Yeah.
that's definitely t-shirt worthy.
We're kind of easy, you guys.
Yeah, I'll bet that's a controversial subject up there is, can we do that? And, what's the pros and cons of doing that? And everybody's got a stake in that. The people that manufacture the equipment, the people that have to make sure that their valves can handle that kind of temperature. So I understand the intent there, but that's a big step, I think. So we'll see where that shakes out. Yeah, so I mean, we'll have a thread going at the wall at Heating Help there. If you want to talk about this some more, if you have some more information that you want to share, we'll keep talking about the subject. We're not done with this by any means. We'll be doing more Coffee with Caleffi's that we do Thursdays at noon Central Time. We're going to be talking about this topic and more products that we'll be coming out with to address this as we go too. So I think we probably have a couple of housekeeping slides. So there's Kevin over there on the right that helped me tonight. So he's starting tech support. He's now our product manager, but he certainly knows a lot about the support end of it and helps out. We all help out in all the different places in the business, but Kevin's responsible for looking at what's available in our other markets that we have already in Italy or somewhere else and seeing how that can work over here. Bring a product like the Legio mixed valve over here saying, well, yeah, we're, the US and Canada is ready for that product. So that's Kevin's job to stay ahead of the game and make sure that we've got something that's nice and unique and equal or better than what everybody else is doing out there. And I think in the case of this right now, we've got a pretty good mousetrap for it. So if we can help you with information or a product or something like that, let us know. That's what we'd like to do. And the rest of the team there, tech support, Greg and Dan on the left. Cody's a tech support and a trainer. He works with me doing training for you folks, webinars and visits and stuff. I think that's about it. Yeah, so that's the next Coffee with Caleffi that's coming up. Cody will be doing that. We'll probably tag team a little bit on that. Cody will be the lead. I might be there making sure he gets it right. So that's September 24th, a little over a month from now. We'll be talking to you again. Let's see what else I've got here. Yeah, different places that we hang out that you can see us on LinkedIn and YouTube and Facebook, Twitter, all the different social media sites. We try and maintain a presence there to answer any questions or show off some jobs or have a contest going on from time to time that you can win some recognition and some prizes. So again, to make a long story long, thanks everybody for hanging in there at this time of day, wherever you might be tuned in from. Anything else, Mark? Any other questions or anything that we could?
Yeah, here's a question, and there's kind of a trail of comments associated with this, and this is back to a commercial system with risers research system, and maybe I can direct this question to Kevin. Kevin,
Okay.
is there anything that can be done or Caleffi does that will maximize the flush or capability of each of the riser circuits to get disinfected? The concern is that probably the insufficient flow that typically happens in the secondary circuits.
Yeah, use if you're not familiar with thermal balancing valves, those are the best balancing valve in the market to make sure that each of the recirc loops is balanced properly, because they control temperature. They are a temperature solution to a temperature problem. So the thermal valve will modulate the flow. It'll actually open and close. That's also something that's unique about a thermal balancing valve. And so if you think about, say you have a takeoff branch that's too cool, for some reason that is cooled down, the valve will open up and bring more of that recirculated hot water to that branch. So they work great in that they're dynamic. So as the system changes, as things open and close, they will respond to the changing dynamics of pressure and temperature in the recirc system. So they're fantastic. Yeah, there you go. That's the hydronics issue you want to look at, number 21, that talks about recirculating and thermal balancing. They work great, especially in conjunction with smart pumps that speed up and slow down. So what you're really doing is putting dynamic control into a basic recirc system, as opposed to using a fixed manual valve and a fixed speed pump. So these valves respond, and they work excellent when you're going to do elevated temperature and thermal disinfection too, because they can work closely with that elevated temperature to make sure that each of the circuits gets up to temperature appropriately.
And it's been such a successful product for us, Kevin. I think you're bringing in a larger size of this because people said, yeah, we love your valve, but on the bigger buildings, we need a little bit higher CV of that valve. So I think you have a 3/4 version coming in. Is that?
Well, we have today a 1/2 inch and 3/4, which covers, I'm going to guess, 80, 85% of the time, but we have 1 inch and 1 1/4 inch coming out real soon too. So for those larger recirc lines that serve a multitude of fixtures, they may be 1 inch or even 1 1/4 inch when you have a big recirc riser. So those will be available pretty soon.
This is likely to get to be a, I won't say crowded market, but up until recently, there hasn't been too many manufacturers supplying this type of valve into the US and Canada. Probably the pioneer was a company called Thermal Megatech.
Megatech, yeah.
And they've been, working in the engineering community for some time now. Theirs is a stainless valve. I don't think it's adjustable like ours, but more recently, Xylem, I guess this is full disclosure, Xylem has a thermal balancing valve line, as does Kemper, or maybe is that it, Kevin, as far as the manufacturers?
Adjustable.
Yeah. For adjustable, yes, that's it for now. I mean, there are others, looking at entering this market, but yeah, it's like you said, the market was really defined by that circuit solver by Thermal Megatech, and they did a great job working with the engineers. But now that people understand it, it's a completely different animal, right? It responds to temperature and modulates. And once you get the idea and you see how they work and what a problem solver they are, then I mean that's really a booming business right now.
Yeah, and that's a retrofittable valve too. It's not just for new construction. In fact, if you have a building that's having balancing problems, which is why I was in Oklahoma City here a couple of weeks ago, they had a hospital building down there that from day one they've had problems with balancing that domestic water recirculation. So this is an application where they'll go in and they'll retrofit not only these valves, but they'll put a delta P pump in there so that recirculation pump will modulate as these valves open and close. The pump will adjust along with it, change its output. So their pinholing issue, it's been going on for 10 years, and that building hopefully will go away, as well as getting a handle on their balancing issues, their temperature fluctuations and that. So yeah,
we still have over looks like over 80% of the people that started the webinar. You got time for another couple questions, Bob, Kevin?
Yeah, I do.
Yeah. Sure.
Okay. So this was a comment. I'm not quite sure when it came in and what part of the topic, but a comment was, I do not understand recommendation for non-aerated faucets. Non-aerated faucets. Was there a recommendation for non-aerated faucets?
I didn't have it in here, but I understand what he's saying, because that's what the aerator is doing, is, bubbling that water. I mean, I think the original intent for aerators, as I remember, is so when you put your hand under a stream of water, it doesn't splash all over you, back whenever we first started seeing aerators on faucets. But, and of course now they put flow restrictors in them also, but.
Yeah, I snuck that bullet in there, Bob. Sorry about that. But that actually came up in an engineering presentation, that, the faucets, when you open them, it's just a nice laminar flow that just sort of flows out and doesn't spray all over.
Yeah.
So that's a very small thing, I think, but it could reduce aerosolizing the water, right? So specifying those is just another little thing that can be done to reduce the amount of water droplets that could be inhaled, maybe if you're washing your face, or splashing water. So
good point. Good question. Something good for somebody to catch that. All right. Anything else, Mark, or?
Yeah, here's a question. The Legion mix, this is my question.
Okay.
So you mentioned the Legion mix. You showed the schematic where the Legion mix actually sends an output signal to a recirculation pump to energize it. Is that right?
Well, it closes a contact, and you can wire that contact in parallel with whatever is controlling that recirc pump.
To increase the head of the during the disinfection process, since you're taking advantage of the recirc pump, which might be set for just basically, just imparting enough, flow to give you constant temperature at the faucet. Is there a way of bumping up the speed of that pump to high speed in that process of closing that contact? Can you, if you got your pump set on a certain value for your calculated no demand situation, and now you want to go into thermal disinfection, is there a way of adding more head to those risers to get more flushing, if you will, by taking advantage of the higher speed of the primary pump? Yeah.
Yeah,
I don't know. Can you turn those
output,
pumps?
Oops, sorry. If we had a modulating output on it, Kevin, that could drive a pulse width modulation or some kind of signal coming out of the control instead of just a dry contact, which would be over here on the relays. It's just, like I say, a dry contact that you can drive that. But if that was a Delta P pump, that would respond to the thermal balancing valves. But if you wanted to just boost that up to high speed, like Mark was talking about, you'd have to somehow get a signal to that. I mean, there's pumps that can take those signals. I don't think we have that signal built into the control right now.
No, we just have the relay. I mean, I suppose you could add a double pole, double throw relay, and
yeah,
if you had a pump that would take another digital input and turn it up to full speed, theoretically you could do that, but I don't know of any.
Yeah.
Okay. I guess it would have to be, especially designed for the application. Here's another question as it relates to safe opening. One of the things about the use of thermostatic mixing valves is even though they're not billed as a self-cleaning valve, they do respond to pressure and temperature that causes a little bit of a wiping action within the valve. When a building is in disuse and those valves aren't exercising, and eventually you do come back on, is there the issue concerning thermostatics that could cause it to, if you have a older valve, that now it might really start acting erratically and therefore unsafely?
Yeah, I mean, if you get a scale buildup in there that cylinder, piston, whatever you want to call it, or cartridge can't move up and down freely, they don't get, it can stick in there in one position or can hunt around where it's kind of a jerky output. So yeah, that's certainly a potential. That's, the more mixing valves you put in these buildings, if you start putting one at every sink in that building, you're going to have to maintain those valves. All valves that see water at some point need to, have service or replacement if you have especially if you have hard water. And the other thing we talked about, if you go to these elevated temperatures, the higher the temperature of the water, the more the minerals precipitate out of that water. So if that valve sees that all of a sudden 140, 150, 160 degree water, it's probably having more potential to scale up than it did at 100, say 30 or 40 degree, assuming you're mixing down to 120 on the mix side of it. So yeah, it's going to be and that in the Legio mix, we tried to build that function into it where we can turn that ball in there kind of like a windshield wiper and clean that off. Because think about it, that valve is probably only operating in a small range most of its life. It's got cold coming in, it's got hot coming in at consistent temperature, not moving much. So it can get a little scale buildup that if it does have to move, for high demand, or you get a fluctuation in your hot water temperature that's got to move, that's when you can have an issue. So by exercising it, by turning, I think it goes one way and it goes the other way, doesn't it, Kevin? 180, something like that. Yeah. It'll exercise that ball so you can wipe that scale off, so to speak. So it should be a little less maintenance prone than some of the cartridge types that are just sliding up and down.
A related question. This just came in from Todd. Is there a Legionella risk with domestic residential wells?
I think there's a Legionella risk anywhere. I mean, even cold water at a certain temperature can have Legionella, and that's the thing. I'm thinking like Phoenix, Arizona. I lived down there one summer. I think the water comes out of the mains there in the summertime at like 85, 88 degrees in some summers when it's under that hot asphalt. So certainly Legionella can live and grow in those temperatures. I would think the safer water would be the water in Milwaukee in the wintertime where it goes down to 35 degrees, and those above storages, it probably isn't thriving in that water. But yeah, if you have water in the building, even the ambient temperature in that building, can start bringing. I think we had that graph. Did we have a bacteria graph in there, Kevin, that shows where it lives and reproduces and what temperatures it starts to really enjoy the piping.
Yeah, that slide you had that kind of showed the cutaway with the bacteria living in there, and then the temperature graph next to it. So one thing to remember is that Legionella is everywhere. It really is just a matter of controlling it. You're never going to eradicate it 100%, pretty much no matter what you do. We just need to control it. And the way to do that is to keep the hot hot, keep the cold cold, keep it moving and keep it fresh. That's a quote I picked up from one of the Legionella conventions. And if you think about that, if you keep the cold cold and keep the hot hot, then you're minimizing the the proliferation of that bacteria, and keep the water moving to keep the bacteria down, and keep it fresh, because bring it in fresh water. That's water from the municipality or from the well, right? The water that comes from your well is probably safe when you pull it right out of the ground, right?
55 degrees, yeah.
Yeah.
Trying to see if I could find that slide quickly. Sorry about the jumping around, but yeah, I mean, like I said, we've done other presentations on this, and we'll be doing more. So we've got other slides. I would certainly steer you towards some of Ron's articles that he writes, as well as some of his. No, this isn't. Let me bring it up some more. There you go. There you go. Thanks, Kevin. Good eye. Yeah, so this kind of shows you the temperature scale and what happens at the different temperature ranges. So.
And remember, it's a time and temperature. There are two variables when it comes to killing Legionella. If you look at that 140 degrees, for example, it says 32 minutes. Well, this is like laboratory conditions, right? If you have a pipe that has a lot of slime and a lot of buildup inside, you'll have to use higher temperature or go for a longer time. So these are like ideal conditions. So you really want to be above 160, up in that red zone up there in the kill zone. And then if you have nice clean pipes, then you can have a pretty short cycle, but if you have old dirty pipes, you may have to circulate 150 degree water for an hour to protect. And the way you know that eventually is by testing. You need to be able to test that water, and you can adjust your schedules accordingly. And as long as you keep testing it and make sure that it's safe, then you can reduce either the temperature or the time, one of the two, until the point where you start to see that the concentration is getting to a dangerous level. So that's how you maintain it.
And I think that's probably somebody in the state of Illinois saw this graph and said, well, here's what we want. We want to get in this shorter time frame. And maybe that's where they were trying to come up with these temperatures up in this upper range. I don't know. But like Kevin said, it's the time and temperature thing. And if you've got a building where you don't want it at an elevated temperature for any longer than absolutely necessary, then that's where you go, to the higher temperatures.
Yeah, and storing at 160 is a good idea, right? Because as long as your tank is okay storing at that temperature, then if you want to do a thermal disinfection cycle, you just start drawing that water. You don't have to wait for your source to heat that tank back up, right? So you're just storing it at 160 all the time, and at any time that you want to, you can start pumping that water to kill bacteria.
Well, and you extend your hot water from that tank also at the elevated temperature. If you're storing at this and you're mixing it down to, let's say down here, typically 120, 122, then you got a little more capacity out of that. But like we talked about earlier, you're probably going to shorten the life of that vessel or that tank that's storing at the elevated temperatures. There's trade-offs to all of this stuff. You just have to find the sweet spot or the spot that works for you and your customer, and just kind of customize it. It's like any other job in our trades. If you're doing a heating system for a customer, you want to kind of design it to their needs and their building and what they expect out of it. It's just when we start talking about Legionella, now we get into a health safety, so it's a little different. If you got a cold spot in the radiant floor, you're probably going to live through that. But if you're susceptible to bacteria, like Kevin was saying, the boomers and stuff that are in these retirement homes, that'll be neat one of these days probably. That's where we've got to we got to come up with a plan. We got to protect these people.
Well, it's a cost versus risk, right? You can say, oh, I can't afford to put anti-scald valves at every fixture, or I can't afford to, keep my storage at 160. Well, okay, there's some good arguments there, but the cost of one outbreak is brutal. You can shut down a hotel in a downtown city for 2 months. You know, the cost of that is just huge. So it's that's what it's about.
Yeah.
Todd's question was domestic systems, residential systems on wells, but I guess the question I would have, maybe Kevin and Bob, do you hear much documented cases of Legionella, let's say major cases, deaths, as it relates to single family and typical residential units, or is it primarily the commercial sector we're talking about?
Yeah, you won't see that in a single family residence because normally you're going through all that water every day, right? An average family uses, what's the number, Bob? I can't remember. You know, way more water than is stored in the piping in a home, right?
Yeah.
So all that water is replenished every day. So it's not an issue for that kind of residential application.
How about a second home?
Yeah, that's well, then you've got stagnation. Bob talked about that. Then you're looking at stagnation. And if you do have a lake home or a ski home, when you go there, you really need to flush out everything for a significant amount of time.
Okay. All right. I think that does it on the questions from what I can see here.
Okay, well, thanks again, everybody, and thanks team at Caleffi for working with me on this, and we'll see you on the Coffee Caleffi. We've got some other interesting things too. We've got some podcasts coming up that we'll be talking about here shortly, so we'll be in touch with you folks.
Thanks, Bob.
Aaron or anybody, but I think that's, there we go. Thanks, Aaron, for helping us with this.
Thanks so much.
Good night, everybody.